Okay, so the very first thing we're going to talk about in geometry is a point. All right, so if you really like drawing, if you're good at it, you're going to enjoy this part of the notes because we're going to be drawing stuff. So all you got to do to make a point is make a dot. Wow, cool, neat. And then we're going to name this dot. We're going to name this point A. All right, so when you see a point, it's usually named as some kind of letter. You could technically name it anything. You could have a point and we can name it star. We can have a point and name it smiley face. You can name it anything, but typically we're just going to use a letter. And then the notation is you call it point A. So not real creative right there, you literally just write it out. All right, and a point has 0 dimensions. You can't measure a point. There's no length, there's no width, there's no height. It's a literal single point in space, and it's just represented by a dot. So it's your most basic thing. Again, we're building the foundations right here. We're gonna do really cool stuff with parallel lines cut by a transversal. We're gonna do quadrilaterals, circles, pyramids, polyhedrons. You can't do any of that stuff unless we know what a point is. So that's why we start there. Next is we have a line. All right, now here's a picture. So what's important is that we have at least 2 points. And we're going to elaborate more on that in the future. At least 2 points. I'm going to be really creative. I'm going to call this point A and that point B. And then for fun, I'm going to put a cursive L right here. I'm not sure if you guys learned cursive back in elementary school, but that's that right there. The notation is, we got some pretty cool notation. You can call it AB and put a little line hat on top. Or you call it BA, put a little line hat on top. Or we could write line L. All right, so that's the notation. When we talk about lines, you'll see all of that. So line L, realize something I forgot to mention. L is not a point. It's just a name for the line. All right. You notice how there's no dot or anything next to it. And then for fun, if I put C right here, that's another point on the line. I could call it line AC, you could call it CB. There's a bunch of different combinations you can call this line. You just need to use 2 points, only 2 points, and put the little line hat on top. And then you could even write that out if you want. You could write line AB, all right? So properties, extends infinitely in 1 dimension, all right? Whatever you want to call it, but a line does exist in 1 dimensions, and in geometry, lines aren't curved, all right? So like if we're ever talking about circles or some kind of curved line, like maybe you should remember what a parabola is from last year, those aren't lines, all right? And extends in 2 directions, all right, but only 1 dimension. And a unique line is determined by 2 points, all right? So we'll elaborate more on that in the future, but a unique line is determined by 2 points, all right? Now, points can be collinear or non-collinear. What do you think the difference is? Try to draw an example and writing definitions, all right? So what I really like about geometry, and this is pretty true for almost everything we learn, is that the names are kind of self-explanatory, all right? The names aren't very creative. The theorems we learned are straightforward, no crazy names. Collinear and non-collinear. So collinear all points lie on the same line. All right, all the points lie on the same line. So I'm going to just draw some kind of line right here. call that M A T H. Math. Haha. That's funny that I spelled a real word. All right, we got these 4 points. M-A-T-H. Points. M-A-T-H are collinear. And here's a big fact. All right, this fact is an important fact. And you'll see this fact pop up later, maybe on a test, maybe on a quiz, something like that. Fact: any 2 points are collinear. So the line doesn't have to be drawn, but if 2 points exist, a line can go through them. So we can put a point here on Earth. I'm not sure where you guys are at right now, but if you're here on Earth, you put a point, and then if you go to Jupiter and put another point, you can make a line that goes through both those points. Put a point on Pluto and put a point on an asteroid. You could draw a line that goes through both those points. Any 2 points are collinear. And then non-collinear, hopefully you guys can guess that by now. Non-collinear not all points lie on the same line. So let's see, go ahead and draw a line. Notice how we put arrows. It's very important. These arrows right here mean it goes on forever and ever and ever. So technically it exists. It goes through your screen infinitely to the right, and goes through the other side of your screen infinitely to the left, and never, ever, 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 ever ends. All right. And then let's make some points on here. We're going to use D, A, R. Actually, hold on. Time out. R, B, Y. So in this case, points, we could do a bunch of different combinations, but like we can say points D, A, R aren't collinear. They all don't lie on the same line. Don't lie on same line. However, we're going to use this cool fact that I discussed earlier. This fact right here. Any 2 points are collinear. Points R and A are collinear. Using that fact, any 2 points, you can draw a line through. Watch this, it's going to be super cool. I kind of missed. Uh-oh. We'll just make it a little bit thicker. There we go. Hit them both. All right. Any 2 points are collinear. In fact, the shortest distance between 2 points is a straight line. So when you're measuring distances, you always just want to use a straight line. It's the shortest distance. When you're traveling, you always want to go straight there. It eliminates the amount you have to travel. All right. That's it for this video. Stay tuned for more.